Hi, thanks for watching. This is my capstone, Deliverable 3 by Jared Valdez. This is the cabin reservation system proposal. So we're going to do a brief presentation of this system. Here's the table of contents. There's 5 different sections. We can have an introduction, problem statement, the architecture design, the interface design that the user or the employees are going to use. We have the measures of success, project schedule, which is in a Gantt chart in figure 4A, milestones and deliverables, figure 4.7. We have the budget, the feasibility analysis, and then the appendix. The introduction, so this is a cabin reservation system that we're designing. We're trying to phase out their old system, which is used by spreadsheets. According to Inc.com, did you know that nearly 90% of spreadsheets contain an error? So, a spreadsheet error brought down restated income by $11 million. Fannie Mae found an error that overstated earnings by $1.3 billion. Again, this is quoting Inc.com. Continuing to have spreadsheets will prove costly in the long term and will only bog down business. The organization, we have a diverse skill set such as analyzing system requirements, database architecture, and creating and optimizing data models, database design, database schema creation, and quantifying data to make it auctionable. The management structure within our organization is a flat structure where employees report directly to their supervisor. Currently, our team of 1 has the capacity to draft a proposal based on the requirements gathered in the initial stages of scoping out the requirements. This allows us to swiftly adapt to what requirements are given to us in the preliminary stages of what our development efforts are trying to achieve. You have the requirements. So, in collaboration with our team and stakeholders, we put together the current system and built out the future system based on the specifications. So if we go down, we're going to have the architecture design in 2.2. The architecture design is displayed by use case diagrams, level 0 of DFD, a high-level overview of the system. And then you have a use case diagram for maintenance requests, the processes that are included. You have a use case diagram for booking reservations. You have an activity diagram in figure 2.3a that shows the processes that they're going through when making a booking or a maintenance request. In figure 2a, you have a physical ERD. This is the database that has been created, and it's showing the data types on the right. Then on the left, you're going to see primary keys and foreign keys tying the database tables together. As you have guests, a guest is related to reservation. You have the reservation ID in the guest table as a foreign key with it as an integer. And then you have middle initials, email, phone number, street address, city, repair log ID. This is the repair items for the maintenance issues that are within the ticket. The maintenance issues from the maintenance orders are tied together with the maintenance orders table. As you can see on the right, you have the data types, which is they're all integers. You have the cabin maintenance order ID, which is a primary key. You have a foreign key, employee ID, and then you have the foreign keys and primary keys tying it all together, such as you have in employees table, you have a cabin ID as an integer, and it's listed as a foreign key. So it's tying it back to the cabins table, which is the specific cabin ID. This is the specific ID, and as you can see, it's a primary key in the cabins table, which is showing that it's the main ID within that table. So it's identifying that cabin, the specific cabin for maintenance orders, for bookings, and so forth. That's in figure 2A. As you can see in figure 2A, there's also cardinalities of the tables and all of the data types that the values take. If you look at the cabin rental history table, you find that cabin ID is preferenced with along with cabin ID to connect to specific cabin to specify again, like I was saying before. And then here's the interface design in 2.3. The interface will allow users to navigate between many different tabs that correspond to requested data. If you wanted to see what booking that customers booked within a certain time frame, This information will be available. If you look in Figure 4, A, A7 issue tracking, you will see that in this screen, in this interface, employees can enter new issues, which are maintenance tickets. They can save it, save and close. You have a summary, which is a cabin bed support beam breaking, the priority, which is critical, and then the description, the cabin bed support beam is breaking and needs to be fixed as soon as possible. Then you have the keywords to help better filter within the system that we've created. So if you want to find this issue or ticket later, you can search it by support or cabin repairs, and those specific keywords are tied to this specific ticket. This is useful for employees to keep track of what is priority in their queue of maintenance tickets, allowing for easily management of the cabins and their maintenance issues. In Figure B2, you will find the reservation details page, where new reservations are entered. From this screen, users will be able to select the cabin by its name along with the clickable button for the option. So here you have, I added a button, allow maintenance visits when occupied. So that's the interface. Here's our quality assurance plan. We're going to create testing environments, our sandboxes, to prevent any alterations of deployed systems, which will prove beneficial and prevent any accidental alterations to important data. This will help minimize risk. The expected project results. This is basically what are the results of this project, the architecture design, the diagrams that are included. We're going to create standard operating procedures for employees to follow so they can learn the system, and which will help make the implementation faster and the adoption rate higher. We're trying to increase the adoption rate based on the measures of success, which is in 3.1. Our measures of success, adoption, we want an adoption rate of 80%, and 5 hours for anything related to plumbing. We want to reduce 10 hours based on priority entry to the system. So reducing, again, that time frame for inception, when the ticket started, when the ticket ends, and the processes in between to make it easier and faster and more efficient. Here you have the project schedule, which is going to take 320 days from each phase, from analysis, design, and implementation. You have milestones and deliverables and a neat task, activity, and completion date. And they have all the tasks right there. This is basically the timeline. This is the Gantt chart, better organized right here in milestones and deliverables. You have the budget, which is in number 5, where I created a budget in the amount of $123,510. You have the salaries, the analysts. You have different tiers of developers, junior, mid-level, and senior, with the rate of pay, the units, and the total. And the project equipment that might be needed, service maintenance, ongoing maintenance packages. We also have the feasibility analysis, technical, economical. This is basically the technical aspects of the project, the economical aspects of the project. We have subject, evaluation, cost of system study. We have cost of packaged software and software development. That's going to be in Figure 6.1. We have operational. We have estimated workloads. This is basically, here we in Figure 7, we compare the current system to the proposed system. Again, like I was saying, they had spreadsheets. What are we going to do to fix that? What are we going to do to fix the processes that are redundant, that are bogging down the business? That's the whole purpose of this proposal. So that kind of compares them both in Figure 7. So upon analyzing the comparison, it becomes apparent that the new system will relieve employees of previous tasks undertaken. These tasks were inherently integrated into the roles due to the technological limitations imposed on the reservation process. The updated process facilitates the automation of booking reservations without any human intervention. And then, moreover, it enables the new reservation system to manage bookings, logs, and customer booking cancellations. Consequently, the cabin reservation system will oversee the booking, adjustments, logging, and cancellations of reservations. This, in turn, allows employees to dictate their effort to the operational aspects of the business, eliminating mundane tasks from their workload. The reservation system will prove and provide designated booking timeframes, including slots for cabins, amenities, and cancellations. Constant computer accessibility will be necessary, as our system will eliminate the need for personnel and their presence to handle cabin bookings over the phone or by email, which will be implemented by this system and replaced. Again, here is the appendix. You have the cabin reservation system version V2, the physical with the data types. Here you have use case for managed requests. You have current cabin reservation system. These are the use cases. And then you have the activity diagram, and then you have the works cited page. So this is a total of 31 pages in this proposal. You have all the diagrams. You have the high level overview right here. You have the use case diagram. Again, thank you for watching. This is the cabin reservation system proposal by Jared San Valdez. Thank you for watching.